Yo guys, welcome to this new episode. Today we will talk about hypergiants and supergiants. I'm a little sick, so maybe you can hear it on my voice. Okay. We will talk today about gigantic suns in our universe. I will tell you today 11 facts about hyper and supergiants. So listen, relax, and most important, learn. Okay. 1. The top 3. The biggest star. The biggest hypergiant is Stephenson 218. Stephenson 218 is 2,150 times wider than our Sun. That means that the Sun can fit 10 billion times in Stephenson 218. Suppose we place Stephenson 218 in the center of the solar system. Then its photosphere, the deepest layer of a star atmosphere, would extend behind Saturn's orbit. Stephenson 218 makes part of the Milky Way, but he is 18,900 light years away from Earth and is in a cluster with 25 other supergiants. The second biggest star is LGGC G00 4539.99 plus 415404.1, and he is located at the Andromeda Galaxy. This star is 1980 to 2377 times wider than our Sun. On the third place is MSX LMC 597 and is 1882 to 1953 times wider than our Sun. He is located in a large Magellanic Cloud, a satellite galaxy of the Milky Way. The satellite galaxy of the Milky Way. 2. The first stars in our universe were hypergiants. Short after the Big Bang, the universe was dark and warm. But slowly the expanding universe was cooling off, and the first stars were born. At the beginning, there were only simple elements like H2 hydrogen, He helium, and a little Li lithium. From observations of CR7, a young galaxy from the early universe, shows that large stars formed in clouds without heavy metals, that were hundreds or even 1,000 times heavier than our Sun. These population 3 stars lived for a very short time, possibly several 100,000 years. But they were very important for the evolution of the universe. These stars quickly convert light elements into heavier elements such as oxygen, nitrogen, carbon, and iron. Without element, we wouldn't live. We are made up of elements. They are important for the existence of life. 3. The best known supergiant is called Betelgeuse. Betelgeuse is 764 times wider than our Sun. Suppose we place Betelgeuse in the center of our solar system. Then even Mars would be swallowed by the red supergiant. Betelgeuse is the brightest red supergiant from Earth's surface and is part of the constellation Orion. So you can see the star quite easily on a clear winter evening. In fact, if you look at Betelgeuse, the star has a red color compared to, for example, the star Rigel in the same constellation. Betelgeuse is remarkably visible because the distance between the Sun and Betelgeuse is relatively small, about 600 light years. This nearby star is about to explode. But don't worry about it, man. Fortunately, the distance is large enough and it can take millions of years before you really explode. The great advantage of a nearby giant star is that Betelgeuse is often studied in detail by astronomers. 4. Hypergiants are fuel guzzlers. Hypergiants are not frugal stars. That's why they are not getting too old, you know. Our sun is 4.6 billion years old and will burn for another 5 billion years. Hypergiants burn the fuel through it at a rapid pace and therefore life very short, just a few million years. The more mass a star has, the more nuclear fuel a star has, and the faster the star burns as fuel, said Professor Steve Eganbury. Because supergiant life is so short, they are rare. 5. Red supergiants are way colder than our sun. The surface of our sun is 6,000 Celsius. That's 10,832 Fahrenheit. Red supergiants are way colder. They have a surface temperature of 3,000 Celsius. That's 5,460 Fahrenheit. That means that the stars are colder than some exoplanets. For example, exoplanet Kepler 70b. The temperature of the surface of Kepler 70b is 6,800 Celsius degree. That's 12,272 Fahrenheit. A good example is Betelgeuse. This star is 100,000 times brighter than the sun, but its surface temperature is slightly above 3,000 Kelvin, which is about 2,750 degrees Celsius, and over about 4,982 Fahrenheit. 6. Hypergiants change into hypernovas at the end of his life. At the end of a star's life, there is not enough nuclear fuel left, and the core becomes increasingly heavier as its own mass flows towards the core. Since a star no longer produces energy, the objects cannot counteract the enormous pressure of gravity. Eventually, the star core collapses, creating a supernova. In case of a hypergiant, there is even a hypernova formed. Hypernovas are the heaviest known explosions in the universe, excluding the Big Bang. The power of a hypernova is 100 times bigger than a supernova. A hypernova briefly shines much brighter than an entire galaxy full of billions of stars. If a hypernova were to occur within a few hundred light years of the sun, this could potentially lead to a mass extinction on Earth. X-rays and gamma rays from the hypernova can ionize nitrogen and oxygen in the atmosphere, creating nitrogen oxides and drastically altering life on Earth. Luckily, we don't have a hypergiant nearby. 7. Supergiant Eta Carinii losses one sun a year. Eta Carinii is an impressive star 7,500 light years away from Earth. The star has a weight of 82 suns, but used to be probably much more massive. 200 years ago, this star had the same brightness as Sirius, but after 1816, its brightness diminished. The reason for this, because there were a few big explosions. This explosion released the same amount of energy as a supernova explosion. This resulted in two large gas clouds that are now 0.7 light years in size. The total amount mass of this gas cloud is estimated at 30 to 40 suns. This means that Eta Carinii lost about 1 solar mass per year in about 20 years, from 8040 to 8060. That's unusually high for a star. Astronomers expect the star to become much brighter in the coming decades as the dust nebula around the star slowly disappear. 8. The born of a hypergiant is just normal. Okay, you may think that a hyperstar forms in a different way for a simple star like the Sun, but that's not the case. All stars forms at the same way. Clouds of gas and dust are slowly pulling together. At some point, part of such a cloud collapses under its own weight. The core gets hotter and the cloud starts spinning faster. At some point, a protostar is formed. Nuclear fission has not yet taken place, but the protostar has already given off heat. Only later, when the pressure and temperature in the center of the protostar increases greatly, will the nuclear fission start. In 2010, scientists found a particularly massive baby star called IRS 134816124. This baby star is 20 times the weight and 5 times the size of the Sun. Like other baby stars, IRS 134816124 is shrouded in a cocoon of dust. Our observation shows that formation is the same for all stars, regardless of mass, concluded study lead author Stephen Krauss. 9. Superstars can disappear right now. A monster star could be seen in Kinman, dwarf galaxy, for a long time, but in 2019 scientists could no longer find the star. To our surprise, we found out that the star was gone. It's strange that there was no super or hypernova. There are two possible theories for the star's disappearance. The bright blue variable star may have been changed by an eruption into a less bright star, which is also partly obscured by dust. That could be possible, but there's another theory. The second theory is that the star collapsed into a black hole without a supernova explosion preceding it. However, that would be extremely rare. As far as we know, massive stars end their existence with a supernova. If so, it would be the first direct detection of a monster star ending its life in this way. 10. Red, yellow and blue, but no green supergiant. Giant stars come in different colors. There are red supergiants, yellow supergiants and blue supergiants. The color of a star reveals how warm its surface is. The blue supergiants are the warmest, followed by the yellow and the red supergiants. Stars can change. For example, a blue supergiant can increase in size and eventually turn into a red supergiant. Our Sun is currently a yellow dwarf star, but will transform into a red giant, not a red supergiant, in billions of years. A famous supergiant is called Rigel, at a distance of 800 light-years away from Earth. The star is 70 times more massive than the Sun, but emits 40,000 times more light. The star gives off so much light that Rigel illuminates nearby nebula, such as the Witch Hat Nebula. 11. Last one. Supergiants are not perfectly round. If you look at the Sun with eclipse glasses, you will see that the Sun has a clear edge. Our mother star is a nice round ball. This does not apply to hypergiants. Hypergiants and supergiants lose a lot of mass, making the outer edges rather thin. As a result, hypergiants do not have a clear edge, but a blurred edge. This also makes it much more difficult to determine the size of a hypergiant and supergiant, because it is not always clear where gas stops and the vacuum begins. Okay, my guys, that was it. I hope you learned something new today about stars, supergiants, hypergiants. I think it's very interesting. I see you at the next podcast. Bye, my man.